So let's talk about parallel and perpendicular lines. Parallel lines, you remember parallel is when two lines, they're parallel. They're never going to get any closer, never going to get any further apart. So you can imagine them almost like railway lines. They're always going to stay the same distance apart. On the Cartesian plane, you can imagine, I'll just put a bit more detailing, two parallel lines. So one here, one here. So these lines are parallel because their gradient or slope or m is the same. That's what it means when they are parallel. So if you had an equation or the two, or some points on the lines, you can work out the gradient to test whether or not they're parallel. Let's do some examples. So e.g. 1. Are these two equations y equals negative 2x plus 1 and y equal to 2x plus 4 parallel? Are they parallel? Well, the gradient for the first equation is negative 2, and the gradient for the second equation is positive 2. Those two gradients are not the same, therefore they are not parallel. Okay, and that's what you're looking for. You're looking to see if those if those gradients are exactly the same. So let's look at our next thing, our perpendicular lines. Perpendicular. Now, that means right angled. Okay, so we're looking for lines that are right angles to each other. So you can imagine two lines like that. Of course, I'll draw that a bit better. Like that, 90 degrees to each other. So what does that mean on the Cartesian plane? It means we have our Cartesian plane, and we might have a line here and a line here. Now they're perpendicular to each other. Now you can probably tell already that, okay, that line has a positive gradient. That line has a negative gradient. And because they're at right angles to each other, this is how we get our special relationship between two lines that are perpendicular to each other. And that is when you times the slopes together, when you times the gradients together, you get -1. Another way of writing that is that one gradient is equal to the negative reciprocal of the other. Okay, so let's do some examples with that one. Okay, so e.g. Okay, so we have a line y equals 6x plus 3. Okay. A line crosses it at 1, 9, coordinate 1, 9. It is perpendicular to it. What is its equation? Okay. So we have this line here, y equals 6x plus 3. Okay, so roughly, very roughly, it would look something like that. It's very, very rough. Okay. At that point, 1, 9, another line crosses it at right angles. Okay, so that's 1, 9. What's the equation of this new line? Okay, so we know that this first line has the equation y equals 6x plus 3. So let's figure out this other equation. So we know that because they're perpendicular, that the two gradients times together gives you -1. So the other way I can write that is m1 equals -1 on m2. So our gradient for our first equation is 6. So I'll say, and let's say we're looking for the other gradient. So m equals -1 over 6. So that's the gradient of our new line. Makes sense, doesn't it? This first line was a positive gradient, so the second line must be negative. And 1 over 6. Okay, so, all right, so we know we know we've got to find the equation now. So I can use this method. Alrighty. So y minus 9 equals -1 on 6, x minus 1 minus, oops, got the brackets, minus 1. Okay, so y minus 9 equals -1 on 6, x, -1 over 6 times by -1 gives you a positive answer. Okay, so y equals -1 on 6x. Now I've got to add 9 to 1/6, so I'll get my calculator to help me do this. So 9 plus 1 on 6. So that's our improper fraction, or x 9 and 1/6. Oh, I might actually have that as an improper fraction there. 55 on 6. Okay. So you can also look at MathSpace for examples and, of course, in your book. Thank you.